I'm going to go through this kind of quickly as this is just a review. If you have any other questions, just email me. All right, so for this one here, the rules for the instructions say to simplify as much as possible using all of the exponent laws and do not leave any negative powers. So that means I'm not telling you which one you're working on. You have to know when you're looking at it. So when we look here, we see that we have a -3 power. So that means I need to get rid of the -3. There's nothing else that I can do. So the only thing being raised at -3 is this a. So remember, if we want to make our power positive, we need to take its reciprocal. So since a right now is written in the numerator, I need to drop it to the denominator. So since 6 does not have the -3 to it, 6 will remain where it is, and that a is just going to drop to the denominator, so it becomes a cubed. For this one, we see that we have b to the 4th being raised to the 9th power. So this is a power to a power. And our rule with power to a power is we multiply. So 4 times 9 equals 36. So this is then b to the 36th power. The key thing for this next one, number 3, is we see that everything is put in this parentheses. So 2x is being raised to the 0 power because it's all inside that parentheses. And anything raised to 0 power is equal to 1, so this is just simply 1. All right, so for this one here, disregard this line. I didn't mean to write that. So it's x to the 19th, did it again, x to the 19th over x to the 6. So here we ask ourselves, where is there more of? Well, there's more in my numerator, so that means my answer is going to go in my numerator, so I don't have to worry about anything in the bottom because it's just an x. And we know our rule when we divide is we subtract, so 19 minus 6 is equal to 13, so it's x to the 13th. All right. And then this one here, we are multiplying. So when we multiply with like bases, we know that we add. So we're going to add those powers. 18 plus 19 is then equal to 37. So that means this is going to be x to the 37th power. So all of those questions there, as you can see from the worksheet, they were approaching questions. So those are, if you can only get those right, then that means that you'll be approaching, because it means you can only focus and do one at a time and the more basic problems of those. Now we're looking for n minus, and n minus is now going to be where we're doing, either it might still just be one rule, but now it's a variation of that rule where it adds a little bit more to it. So here we're doing 3a to the 22nd times 9a to the -6. So remember, one of the things that you have to be aware of is these are coefficients. Coefficients tell us how many. They're not being raised to a power. So when we do these rules, the rules, the exponent laws, only apply for when we have a base and a power. So 3 and 9 do not have a base or a power. They are just numbers, coefficients. So we just do the regular computation. So we will just do 3 times 9 because that's what the parentheses is saying. And 3 times 9 is 27. All right, then we look at our a's and the powers, the bases, and we say, okay, well, a, this one has a power of 22, and this one has a power of -6. So since they're the same base, we know our rule is we add, and 22 plus -6 is the same as 22 minus 6, which is then going to give me 16. So this is 27a to the 16th power. All right, so when we move on to question number 7, same thing. Here we're going to focus on the coefficients first because they're not being raised to any power, so we treat them like a number. We treat them as if it's 30 over 10. And if I just gave you that on its own, you should know that 30 divided by 10 is 3. So we know it's then going to be 3. Now we're going to look at the x's because they are powers, their bases raised to a power. So we're now going to apply the exponent laws to them. So first I ask myself, well, where is there more? Well, there's more x's in my denominator, so that means in my answer, the x will have to be in my denominator. And then we can do 15 minus 6, which is equal to 9, so that means it'll be x to the 9th. All right, so remember, we talked about why we can do this in class. If you're unsure, just make sure you're just asking help to get any clarification. All right, so that is it for this page. So let's move on to the next one. So we're still on our m minus questions. And here we now have 3y to the 4th being raised to the 3rd power. So all of this is being raised to the 3rd power. So we can distribute this power 3 into both the 3 and the y to the 4th. So just like when we're doing the division or the multiplying, we're treating this 3 as a number because it doesn't have a power. I mean, technically it has a 3 to the power 1, but it is a number that we can take the power 3 of. So when we distribute this, it becomes 3 cubed, which we know is 3 times 3 times 3, which is then going to give me 27. So 3 cubed is 27. And then our rule when we're doing power to a power, so here we have y to the 4th raised to the 3rd power. We know that that means we multiply. and 4 times 3 is 12, so this then gives me y to the 12th. All right, so one of the mistakes that people are making in class is that because we say, oh, power to a power, we multiply, you're multiplying this 3 times 3 and saying that it's 9 to the y to the 12th power. So you're not treating the number like it's a number and just doing the actual computation with that number. Right? We don't know what the y is, so it's an unknown number, so that's why we have to have these rules so that we can simplify and make it something that we can do easier in the long run. Right? So when we do this next one, here we look and say, all right, well, this is the only thing being raised to a negative power. So to get rid of a negative number, we know we take its reciprocal. So 15, nothing's being raised out, so we can't do anything to that. It is just 15. And since this is in our denominator, we take its reciprocal, which means it moves to the numerator, so it becomes x to the power of 3. So 15x cubed. All right, when we do number 10, it's important that you understand the difference between this term and this term. So here, this 15x to 0, well, the only thing being raised to the 0 power is that x, because you see it doesn't have the parentheses. So that means it's 15 times x to the 0 power, and we know anything raised to the 0 power is 1. So this is the same as saying 15 times 1, or 15. The next one, all of this is in parentheses, so all of this is being raised to 0 power. So that means this whole thing is going to be 1, and it's minus that, so it's minus 1. And then it's plus 7 at the end. So now we just go ahead and just add and subtract these. So 15 minus 1 is 14. 14 plus 7 is 21. Right, now these are M questions. So now they're a little bit harder than the ones before because there's more going on, more variables, and just a little bit more challenging. And these ones are the middle of the line M problems. So same thing though. When we're multiplying these, there's no power outside the parentheses, so I don't have to worry about doing that first. So the coefficients, we just treat them like they're numbers. It's negative 4 times 7. They're not anything raised to a power, so we're not applying these exponent laws. And 4 and 7 aren't the same base anyway, so we couldn't do any law to these because they're not the same number. But negative 4 times 7 is negative 28. And then now we go down the line and say, okay, well, here's an x, and this is the same base. So now that it's the same base, we can apply the laws that we learned. So x to the second times x to the 6, well, we know that we add 2 plus 6 is equal to 8. So it becomes x to the 8th power. Then we move on to the next one. Oops. We move on to the next one. And so that's our y and y. So here when we go to y, well, we have y to the 4th times y. Well, we know that this has a power of 1. When we don't write it, it's what's understood to have. So then we add them together. 4 plus 1 gives me 5. And then the last one that we have, z and z to the 8th. So once again, we have z times z to the 8th. So this is understood to be a 1. So 1 plus 8 is 9. So z to the 9th power. All right, and that will then be our final answer. So as we move on to number 12, same thing here. We're going to just treat these like they are the same, our coefficients. So I can just take these numbers and just, if I gave you 24 or 34 and asked you to simplify that, that's what we're doing here. Well, they're both even, so we know that they're both divisible by 2, and 24 divided by 2 is 12, and 34 divided by 2 is 17. 17 is prime, so we can't simplify it anymore. So I know that this fraction is going to at least be 12 over 17. And now as we move on to the other one, we have our a's. Well, now we know our rule is we subtract, but since 1 minus 4 is equal to negative 3 and 4 minus 1 is equal to 3, since the order that we subtract gives us the same number but different signs, that's why we're asking ourselves, well, where is there more of? So that way we don't have to worry about dealing with a negative exponent. But there's more a's in my numerator, so it means the a is going to move there. So a to the 12th over a to the 10th, we know is then going to mean that we subtract. So 12 minus 10 is equal to 2. So since we knew our a was going to be in our numerator, it's just a to the 2nd. All right, so now we're going to go ahead and move on to our b. Well, we ask ourselves again, where is there more b? The numerator or denominator? So I know there's more in the denominator, so the ending is going to be there. So b to the 8th over b to the 14th. So now I can still do 14 minus 8, which is going to give me 6, and I know that means that b is going to end up in the 6, or in the denominator, so it would be b to the 6th power. All right. Move on to the last, c, and we see, well, where do we have more of? Well, we have more c's in our numerator, so we know it's going to end there. And our rule when we're dividing with like bases is we subtract. So 10 minus 6 gives me 4. So we know that we will have c to the power of 4. All right. Now as we move on to the next question here, remember the coefficients, we treat them as numbers. So when we look at this, we have negative 5x squared y cubed to the second power. So we are then going to this do, well, negative 5 squared. And we know that when we're squaring a negative number, it becomes negative 5 times negative 5. It's going to be positive at the end. So that negative 5 squared gives me a positive 25. And then as we go ahead and use our power rule after this, we know that we multiply with our power to our power. So x squared raised to the second power is equal to x to the 2 times 2 power, which is x to the 4th. And then our last one, as we move y cubed squared, we know then that that is going to be y to the 3 times 2 power, which is then y to the 6 power. All right, so the mistake that you guys keep making is you're treating the numbers like they're a exponent, like they are a base raised to a power. So some of you are seeing this minus 5 and then you're taking a reciprocal of it to put the 5 in the bottom, but that is a negative 5. It's not a base raised to a power. All right, so this next one, we can do this one a bunch of different ways. I like to get rid of the negative power first. So to get rid of that power of negative 2, we need to flip it and take the reciprocal. So 2x to the 7th, y cubed over top of 3x squared, y to the 6th. And now that's all being raised to a positive 2 power. All right, when we take the reciprocal of this negative 2, this is the focus point. That's the one that we're looking at. That's the one that we are saying this is what we're changing. So none of the other powers, even though they're changing position, are turning negative because we're only focusing on this one. And that is flipping and taking a reciprocal of the fraction. And now this is our new problem. And from here, there's different ways you can do it. I'm going to simplify the inside first. 2 over 3 can't be simplified, so it still remains 2 over 3. I have more x's in my numerator, so it will be 7 minus 2, which is then going to give me 5, so it's x to the 5th power. I have more y's in my denominator, so 6 minus 3 is 3, so it will be y to the 3rd power. And then from here, everything just needs to be squared. So 2 squared is 4. Our rule of power to a power is we multiply, so x to the 10th. 3 squared is then going to give me 9. And our rule of power to a power we multiply, so 3 times 2 is 6. So it'll be y to the 6th power. Okay, just a couple more questions and then we'll be done with this. All right, this one may look like the hardest question on the test, but it's actually the easiest. When we see all these things written inside the parentheses, well, we know all of that is being raised to 0 power. So you can go ahead and do all the work if you want, but once we see the whole thing's raised to 0 power, it is simply equal to 1. All right, now these last 2 questions are the m plus questions. They're a little bit harder because it adds a little bit more of each law into the one problem. So once again, there's different ways you can do this. I'm going to first just simplify everything that's inside the parentheses before I go ahead and get rid of that negative 3. So I'm going to just rewrite. 4 over 3 cannot simplify at all, so I'm going to have that 4/3. X, this has a power of 1. Well, 1 is greater than negative 3, so I know it's going to end up in my denominator. And our rule is we subtract, so it's 1 minus negative 3, which is the same as plus. So it's 4, so this becomes x to the 4th power. 2 is greater than negative 2, so I know my y is going to end up in my numerator. We subtract. 2 minus negative 2 is then turned into a plus, so it's 2 plus 2 or 4. I have more z's in my denominator, so it's then going to be 8 minus 6, which is 2, so z squared. And now all of this is being raised to the negative 3rd power still. So since I simplified everything on the inside, now I'm going to focus on getting rid of that power of negative 3. And to do that, I take its reciprocal. So I flip it. So it now becomes 3x to the 4th, z squared, all over top of 4y to the 4th. And all of this is being raised now to the positive 3 power because we just made that negative turn positive by taking its reciprocal. And now we're going to distribute everything in. And by simplifying it first, I don't have to worry about it now at the end. Once I do this power 3 to everything, I'm done with the problem. So 3 cubed is 27. So it becomes 27. Our power to a power, 4 times 3 is 12. So x to the 12th. Z squared raised to the 3rd power. So 2 times 3 is 6. So z to the 6th. 4 cubed is 64. And y to the 4th raised to the 3rd power. So it becomes 4 times 3, which is 12. So y to the 12th. All right, and then this is the last question that we have here. Once again, there's different ways you can go about doing this. I'm going to just multiply the two fractions first, just to show you a different way. Last time I simplified everything on the inside first and then did everything on the outside last. Here I'm going to do everything on the outside first, and then I'll simplify at the end, just to show you a different way of doing it. So when we multiply fractions, we know we multiply our numerator with our numerator. So that means that we are going to multiply everything on the top of both of these. Well, we treat our coefficients like our numbers. So it's 6 times 10, which is 60. And then we have a cubed times a to the 6, which we know then we add those powers. So 3 plus 6 is 9, so it becomes a to the 9th. We have b to the 8th times b to the 7th, so it gives me b to the 15th. And we have c cubed times c to the 6th, which is then going to give me c to the 9th. And then we're going to focus on the denominator and do all these together. So the only coefficient we have is 15, so there's nothing that we can simplify with that or multiply with the 15, so it just remains 15. A to the 5th times a to the 4th, what we add, it gives me a to the 9th. B to the 10th times b to the 12th, we add, so it gives me b to the 22nd. And c to the 7th times c to the 4th, we add, and it gives me c to the 11th. Now, after doing that, the last step is we then have to simplify this fraction. Well, we look at 60 over 15. Well, I know 15 goes into 64 times. So that's just going to give me 4. Here we have a to the 9th and a to the 9th, the exact same power. So that's going to cancel out to give me 1. So that means that we're not going to have any a's. I have more b's in the denominator, so I'll write b down here. 22 minus 15 is 7, so it's b to the 7th. And I have more c's in the denominator, so c will be down there as well. And 11 minus 9 is 2, so it is c squared. All right, and that is it for this video.